we're told that we want how many hours of sleep to be in the top 1%. So in the normal distribution, that means we just want a sliver of this tail over to the right. We want the top 1% over here. So in order to get that, it means we need 99% of the area to the left, and that's what z-score tables tell us. They tell us the probability of getting something less than a certain value. So we want to look in the sea of numbers for the decimal form of 99%. So that's 0.99 right here. This one's probably 0.9901. This one's probably 0.9903. The decimals are cut off. Usually there's 4 decimals in the z-score table, but you want the first one that comes up. Okay, so that's a z-score of 2.31. And so if we plug that in the z-score formula, here I'll type out the formula. It's x subtracted by the population mean. Wait, is this? They gave us a sample size, so this would be x bar. And x bar is the x with a little bar over it. That's the sample mean. And then we divide by the standard error, which is different than the standard deviation, right? So x bar we don't know. We don't know what the sample mean is. Yeah, we don't know what the sample mean is. That would cut that off. The population mean, they tell us, is 7.45. They say for all adults. That's the average. And then the standard error we've got to calculate. On the standard error, what you do is you take the standard deviation that they give you, and they divide by a square root of the sample size. So here's the square root of the sample size as a decimal. I copy that to my clipboard because the standard error is the standard deviation divided by the square root of the sample size. So this is going to be the standard error, and it might say round to 2 decimal places for like when you type in the standard error, but when you do your calculation, I think you need to keep all of them to make Newton happy. Okay, so we need to find x bar. We know the population mean, population standard error. So we can put in 2.31 for the z-score here. X bar subtracted by, we got 7.45. Then we divide by the standard error. Okay, so to get x bar by itself, we just need to do the algebra. We're going to multiply that to both sides. So I multiplied that 0.1186 to both sides. And if we're just getting x bar by itself, I need to add 7.45 to both sides. So I've got 7.72 to the nearest hundredth. That's the x bar. That's the average amount an adult needs to sleep to be in the top 1%. And that's pretty small. That's not that much of a difference, huh? But it's because the standard deviation is relatively small for this. Then we got 30 adults for the sample size.